October 2nd, 2007. A terrible tragedy unfolded in the mountains 40 miles west of Denver, Colorado. 5 contract painters were trapped by a chemical fire deep inside a hydroelectric plant tunnel. The plant was owned by Xcel Energy, a major regional electric power company. The fire, involving combustible coatings and solvents inside the tunnel, blocked the only way out, an opening more than 1,400 feet away. There was no help available because the company did not have properly trained emergency responders standing by for such a rescue. For the workers, there was no escape. The Chemical Safety Board found that neither Xcel Energy nor its contractor, RPI Coating, had adequately evaluated the dangers of the work inside the tunnel.
The RPI contractors entered a confined space with highly flammable solvents, little training, and no emergency plan. From the moment they entered the tunnel, the stage was set for disaster.
Xcel Energy's Cabin Creek Hydroelectric plant is located in a remote mountainous area approximately 6 miles from Georgetown, Colorado. A 4,000-foot tunnel, known in the industry as a penstock, was slightly inclined at the bottom and extremely steep at the top. The penstock carried water between the upper and lower reservoirs. At the bottom, water flowed through large turbines to generate electricity. Over the years, the penstock lining deteriorated. In 2007, Xcel Energy contracted with RPI, an industrial painting company, to recoat a large steel section of the penstock near the power plant and lower reservoir. Work began at the site in September. The penstock is a unique confined space that is difficult to enter and exit. Before the project began, a door was cut into the lower section to provide access for workers and their equipment. On the morning of the accident, October 2nd, RPI workers prepared to begin the coating operation by bringing approximately 10 gallons of a highly flammable solvent called methyl ethyl ketone, or MEK, into the penstock. Some of the solvent was used to clean the equipment and hoses before starting the work. Shortly after 1 p.m., 11 workers began coating a section of wall located more than 1,400 feet inside the penstock. To apply the new 2-part epoxy coating, workers used a specialized sprayer. Base and hardener were mixed and then sprayed onto the walls. But the workers immediately encountered problems. The epoxy was not adhering evenly to the surface. The workers flushed the hoses and spray wands with MEK each time a problem arose. But despite their efforts, they could not get the epoxy to adhere evenly. An RPI foreman decided to clean and remove the sprayer from the penstock. The crew began cleaning out all of the equipment and hoses using MEK. A worker brought in more of the flammable solvent to aid in the cleaning. Some workers noticed the strong odor of MEK as the vapor spread through the work area. At approximately 2 p.m., the vapor was ignited, most likely by static electricity inside one of the spraying machine hoppers. A flash fire erupted. Burning solvent burst from the hopper onto a nearby worker, catching his sleeve on fire. The flames spread quickly, engulfing the open buckets of MEK nearby. 5 workers were blocked from escaping the penstock by the intense fire. The trapped men shouted desperately for fire extinguishers, but there were none inside the penstock. Workers on the other side of the burning equipment ran the 1,400 feet to the entrance to locate fire extinguishers. One worker notified the control room operator to call 911. The 5 trapped workers could do nothing but wait and hope. Inside the penstock, the nearby buckets of epoxy and MEK burst into flames. The trapped men fled deeper into the penstock to escape the smoke. They used their radios to communicate with the workers outside, imploring them for help. Workers repeatedly attempted to fight the fire with portable extinguishers, but they were forced to turn back by the intense heat and thick black smoke. Inside the penstock, the workers continued to wait for rescue. At 2:11 p.m., county emergency personnel arrived at the site in response to the 911 call. But they had not been informed about the hazardous conditions within the penstock, and they were not equipped or trained to attempt such a technically demanding rescue. The trapped workers were instructed to move even deeper into the mountain, but they stopped when they reached the inclined section, which was too steep to climb. They told responders they were struggling to breathe as smoke filled the penstock. Some of the responders entered the penstock on an all-terrain vehicle, but the dense smoke blocked their path, and they had to retreat after just 200 feet. The responders then drove up the winding road that rose over 1,000 feet to the upper reservoir. There, they lowered air bottles and respirators through a small hatch, hoping these would reach the trapped workers below. Finally, at 3:40 p.m., a specialized rescue unit arrived from Denver, some 40 miles to the east. A short time later, a specialized mine rescue unit arrived. The teams prepared for entry, but it was too late. The 5 workers inside the penstock had died of smoke inhalation over an hour earlier. The following day, responders found their bodies near the bottles of air. The CSB found that the accident at Xcel's Cabin Creek plant highlights 3 key safety issues: the lack of regulatory limits for bringing flammable materials into permit-required confined spaces, Xcel Energy's flawed process for contractor selection and oversight, and the lack of preparation for possible emergencies.
Confined space technical rescue poses many unique challenges for us as emergency responders.
Captain Steve Azeltine is the Division Chief of Training for the West Metro Fire and Rescue District in Denver. He and his team responded to the accident at Xcel Energy.
A confined space is not meant for continuous human occupancy. It has a small ingress and egress point. A permit-required confined space is any area that can have an atmosphere that's immediately dangerous to life or health. You're required to have a rescue team on site and professionals there to help you in a permit-required confined space, and most times we see people just blow that off. And unfortunately, those are the people that don't get to go home.
There was 45 minutes between the incident and when the last radio conversations occurred with the workers inside the penstock. That's a significant amount of time.
The fact that there was 45 minutes before the last radio communication tells us that there probably would have been enough time had an emergency responding group been there and been prepared to handle the chemicals inside, to potentially put it out and rescue the individuals.
The nearest community emergency responders trained for confined space technical rescue were located over an hour's drive away.
The fire department in your local area may not have a confined space technical rescue team. They may not have that specialized level of training. They may have to wait for that kind of response. And if you're the person down in there that is in a low oxygen environment, you don't have time to wait.
To increase the availability of such specialized responders, the CSB recommended that the state of Colorado develop a new firefighter training certification program for confined space rescue. The CSB determined that when Xcel Energy was selecting a contractor to recoat the penstock, RPI did not have an acceptable safety record. based on Xcel's own evaluation standards.
In the safety category, RPI was evaluated to have a 0 on a scale of 0 to 5. And that was the lowest possible rating. However, that did not prevent RPI from winning the competitive bidding process, largely based on low price.
Xcel officials determined that another coating contractor had better technical qualifications than RPI. However, that company's estimated cost was higher than Xcel's budget for the project.
Xcel didn't consider safety to be one of the criteria by which RPI could be disqualified.
Xcel did plan to closely monitor RPI's safety performance during the project. However, the CSB determined that Xcel's oversight of RPI remained inadequate. The CSB recommended that the Colorado Public Utilities Commission develop rules governing the selection and disqualification of contractors based on their safety records. The board also urged the Commission to require regulated utilities to investigate and report to the public on all serious accidents. In 1993, OSHA issued a regulatory standard for permit-required confined spaces in general industry. But the Chemical Safety Board identified 53 serious accidents since 1993, where flammable atmospheres led to fires or explosions inside confined spaces. These accidents caused a total of 45 fatalities and 54 injuries. Most of the fatalities and injuries have occurred since 2001. Existing good practice guidelines recommend against working in any confined space where the concentration of flammable vapor exceeds a specific low percentage of the lower explosive limit. That is the lowest concentration of a flammable vapor in air that can burn when ignited. Concentrations below the lower explosive limit, or LEL, are too lean to burn. Concentrations exceeding the upper explosive limit are too rich to burn. Overseas regulations, as well as certain OSHA standards, including the OSHA standard for shipyards, prohibit work inside a confined space if the atmosphere exceeds 10% of the lower explosive limit. However, the OSHA General Industry Standard, which regulates over 4 million permit-required confined spaces across the country, sets no such safety limit. The Chemical Safety Board believes that the limit must be set conservatively because atmospheres can change quickly. Although monitoring is essential, it may not always reveal the full extent of the hazard.
If you don't establish limits, how are workers to know what is safe and what isn't? And it undermines the importance and the recognition of those hazards of a flammable atmosphere.
In its final report, the board called on OSHA to amend the permit-required confined spaces rule for general industry to prohibit entry and occupancy if the atmosphere exceeds a specified low percentage of the LEL.
The incident at Cabin Creek will affect me for the rest of my career. Do I hope that that never happens again? Absolutely. Nobody ever wants to see this type of incident occur, and anything we can do to help prevent that, I think, is invaluable.
Often companies do not properly consider the dangers of working within the unique environment of a confined space. Companies and contractors need to be diligent about assessing those hazards, controlling the risks, and planning for possible emergencies. We hope that our investigation and this video will help prevent similar accidents in the future.
For more information about the CSB investigation of the accident at Xcel Energy, please visit csb.gov.